Good day, good day, good day, good day. Welcome again to Simplified RSA. The guys who makes it looks easy. And I am Mr. My Money. Today we are back to physics again, and I present to you our question of the day, a very interesting one. Like I feel Okay, it is indeed an interesting question with an interesting storyline. On my side, I will read the question from the phone. The question reads, a baby leaves a bowl of food on the floor and crawls westwards to fetch a toy that was placed 5 meters away. At the same time, a dog walks eastwards towards the baby. It takes the baby 30 seconds to reach the toy. The dog walked past the toy to eat the baby's food in the bowl. You see, this is what happens when you leave your child unattended while they are eating, and you know there's a dog in their house, and you know your child might somehow crawl to fetch the toy, like stuff like this is exactly what happened. But anyway, let's answer the question. But then it's fine. I guess people should just learn to look after their children. But then otherwise, let's just look at the questions. 2.1, they want us to define the term displacement in words. 2.2, they want us to determine the position of the dog relative to the baby before they both moved. And then 2.3, they want us to calculate the average velocity of the baby. If the average speed of the dog is twice that of the baby, they want us from that information to calculate how long it would take the dog to reach the food bowl from the moment the dog started moving. Well, besides the whole thing of the dog eating from the child's bowl, I think we can calculate this. So it goes like this. Here's the storyline. So here's our story. We have the dog, and then we have the toy, and we have the child there with the food bowl. The most important thing is they gave us a scale for the direction. So north, east, south, west. The child, here is the toy. The child is approaching the toy westwards, meaning the child is going to that direction. We are dealing with vectors here, so direction matters. Also, we see that the dog is going eastwards, so it's going to that direction according to our direction scale there. So the child is going eastwards and the dog is going, the child is going westwards and the dog is going eastwards. The distance between the child and the dog, the distance between the child and the toy is 5 meters. The distance between the dog and the toy is 7 meters. However, the distance between the child and the dog is somehow the addition of that, but we'll talk about that when we get to that point. So to answer 2.1, the definition of displacement in weight, we say displacement. So to answer 2.1, you will get your full mark by saying displacement is the change in position of an object. You get your full 2 marks by that. I'm telling you, like the marker is just going to go ahead and give you 2 marks like that. So displacement is the change in position of an object. And then moving on to 2.2. So now looking at 2.2, they want us to determine the position of the dog relative to the boy before they both moved. The position of the dog relative to the boy, meaning the position of the dog from how the boy is seeing it at that point. So when the boy is standing here, the dog is that side at the west side, according to our scale of directions there. So the boy is seeing the dog 5 meters plus 7 meters away from him at the west direction. So we're then going to say 7 meters plus 5 meters is equals to 12 meters. That's the distance the dog is away from the boy. But 12 meters west from the boy's point of view, it's that direction, is at the west side. Or you can just say minus 12 from because if that's the positive direction or the positive distance from him, from where this is, because it's an opposite, it's just gonna be minus 12 meters. So whether you decide to take this one or you take this one, the marker would still mark you right. But I'd advise you to go with 12 meters west because it makes more explanation sense that the boy sees the dog 12 meters away, but then at the west direction from where the boy is. So the answer is 12 meters west, according to 2.2. So now on 2.3, they want us to calculate the average velocity of the baby. At this point, we know that the formula for average velocity is given like this, right? And we know the change in distance of the baby from where the baby starts moving to where the baby reaches the toy. The toy and the baby, they are 5 meters apart. And we know that it took 30 seconds for the baby to actually reach the destination where the toy was. Then we just substitute from our formula and then we get the value. But this is how it's done. So 2.3 we say average velocity is equals to change in distance over the change in time. And we know that our change in distance from here to there, it's 0 meters to 5 meters if we calculate the distance from there. And we know that it took 5 meters for the baby to crawl from here to there in a period of 30 seconds. 5 meters in a period of 30 seconds. Therefore, our average velocity is going to be 5 divided by 30, which is 5 divided by 30, which is 0.1666666. So I'll say this approximately 0.167 meters per second because it's meters divided by seconds. So now we are almost at the end of the struggle. Approaching 2.4, it reads, if the average speed of the dog is twice that of the baby, they want us to calculate how long it would take the dog to reach the football from the moment the dog started moving. In this case, we just calculated the velocity of the baby. And then now they're saying if the average speed, okay, we calculated the average velocity of the baby when the baby was crawling towards the toy. Now they're saying if the average speed of the dog is twice that of the baby. When we talk about velocity for the baby side, that's when we're considering both the magnitude and the direction of where the baby is going. So we took the direction where the baby is going as a positive direction, right? In this case, the dog is going to the opposite direction with respect to the baby, such that if I was to consider velocity, I would say the velocity will be negative because we are going to the negative direction. But then since they mentioned the word speed, I only consider the magnitude of the velocity of the baby and then I twice it without considering the direction. So it doesn't matter whether I put a negative or a minus on the dog speed because I'm talking about speed, not velocity. That's the story of vectors and scalars again, but then we're going to talk about that again at some other time. For now, we just have to answer this question. So now, this is how I would approach this one. So now the formula for speed is equals to distance divided by time. But then since we want to calculate time, if I make time subject to the formula, our formula will be like that. T is equals to D over S. I know that the distance is, I know that the distance from the dog to the bowl is actually 12 meters. So it's 12 meters divided by the speed. But now the speed is twice the speed of the child, the speed of the baby. For the baby, we got the speed to be 0.167, and then multiplying it by 2 is going to give us the speed of the dog. So this is going to be 0.333. Then that means I'll divide by 0.33333 like that. Therefore, this will give me the answer. Therefore, this will give me 36.36 seconds. That is my answer. So that's it with the story of the child and the dog eating each other's food. You can see that on this question, we didn't use equations of motions. There was nothing mentioned concerning acceleration in this case. And one can say that the difference between velocity and speed is that one is a scalar quantity, the other one is a vector quantity. Hence, velocity is change in distance over the change in time, whereas speed is just distance over time. We don't really care about the direction of where whichever one was going whatsoever. Hence, we're not sensitive about the signs as such when using the formula for speed. We're going to proceed with more lessons. We're going to talk more about vectors and scalars. For today, that's where I stop. And just for you to know that we're going to continue making stuff like this. All you need to do is just to remember to subscribe to our YouTube channel, follow us on X, follow us on Facebook, follow us on Twitter, as well as on TikTok. Also, you can access our learning channel through Spotify. You just go to Spotify app and search for learning channel. or alternatively, you can just type in simplified_RSA, and then you'll access these videos. I'm Mr. Maimane. This is Simplified RSA. The guys who makes it looks easy, until we meet up again on the next video to make more stuff looks easy. And for today, Niki Metakwala, Mina, Ntukulu Wakozeni.